So this is 2000 and 2010B, because 10A would be 10A is no longer considered to be on the course, I think. Where is it? So just give me a second. So we're going to do 2010A and 10B because they're both doable. So let's start off with 10A. Now, first thing I'm going to do is bring over the 1 over the other side. So we're going to have x, and then I'm going to, once I bring the 1 over the other side, I'm going to factorize out the x and the dy dx. So it's going to be x dy dx into 1 plus y. And that's all going to be equal to 1. Okay? Then I'm going to multiply up the dx and multiply down the x. So we're going to have is 1 plus y dy. And that is going to equal 1 over x dx. Okay? So that's the first part. Now, problem with this one is I have y equals 2 when x equals e, and I also have find the value of y when x equals e squared. So I have y equals y, x equals e squared. So that means I can actually use some limits after all. Okay. So what I did here was I'm going to integrate both sides. I'm going to match my limits. Now, whatever my target is, I usually like to put that at the top. Okay? And then the ones that I have the full set of information for, I like to put on the bottom. So that's going to be E, and that's going to be 2. Okay? Going to integrate. So what we're going to get is integrate 1 plus y. We're going to get y plus a half y squared. Okay, so y plus a half y squared. Integrate 1 over x, and it's ln x. And that's going to be from e cubed, e, and that's going to be y, and that's going to be 2. Let's integrate. We're going to get y plus a half y squared. And then we're also going to get minus brackets 2 plus a half 2 squared. And then we're going to get ln e squared minus ln e. Now, what we're going to do next is we're going to figure out what this part is in here, the 2 and the...
Can you click that back on the side?
Yeah. Okay, so minus a half y squared minus that's going to be 2 plus a half of 4, which is another 2, so we're going to get minus 4. Okay, and then we're going to get ln e squared minus ln e, which is going to be the was it the product, isn't it? What? So it's going to be e squared over e, which is ln e, and ln e is 1. Okay, so that makes it a lot easier now. Okay, what I'm going to do next is going to multiply both sides by 2 to get rid of that half y squared. So you're going to get 2y plus y squared minus 8 equals 2. I'm going to get y squared plus 2y minus 10 equals 0. And as suspected, this is going to be a minus b formula because there's no factors that will do the trick for us. Okay, so b squared minus 4ac all over 2a. Okay, now it might warn me that the positive value, so I'm only looking for the positive value, not the negative value. Okay, so that can be save you a bit of time as well. So what we're going to get is minus b minus 2 plus or minus the square root of b squared, which is going to be 2 squared minus 4 times 1 times minus 10 all over 2 times 1 minus 2 plus or minus the square root of what's that going to be, 44 all over 2. I'm only concerned with the positive version because my answer has to be positive, so I'm just going to get rid of the negative sign there. And then what's going to happen is the answer will be minus 1 plus root 11 in surd form, or alternatively it's going to be 2.3166 in decimal form. Okay, that's part A done. Now we're going to go on to part B. Is that alright? Okay guys, part B. Yeah. So, around 6 minutes for part A, okay, so just be aware of your timing in the exam. Probably should take it probably an extra 2 minutes there, okay. I didn't have to stop for any calculations, okay. So probably extra 2 or 3 minutes. So currently working off 15 minutes for the part B. Now, part B, okay, looks difficult. The deceleration of a particle moving in a straight line with velocity phi has magnitude, what's it, 4e to the phi over 6. Okay, and the particle has an initial speed of 6. Find the time t1 for the speed to decrease to 3. Part 2, find the time t2 for the particle to come to rest. Deduce that t2 minus t1 all over t1 is root e. Okay, so where to even begin with a question like that? Okay, well, the first thing we gotta write down is our acceleration, a, is equal to particle initial speed decreasing. It's decreasing. That's the language is telling you what to do with that. It's a negative. So be very aware of the language. It's a negative, it's a deceleration. Okay, magnitude, they're just telling you, if I said a deceleration of 5, my acceleration is minus 5. But it doesn't actually have, and it also says deceleration. Okay, so the next thing is, so it's negative, okay? So we'll write down some of our information, okay? Speed, phi equals phi, and time therefore has to equal 0. Okay, now it wants phi equals 3, because it wants it to, the velocity to be 3, and then it wants t to be t1. Okay, so, oh sorry, phi
equals 6. Top initial speed is 6.
Oh, sorry, it should be phi equals 6 because it starts off at, you're right, I'd have 2 variables there which is not enough, and its initial velocity is in fact 6. Okay, so then we're going to do our usual, the v dt is a, and that equals minus 4e to the v over 6. We're then going to cross multiply. Now, that e to the v over 6 is going to have to come down together, okay? So it's going to be 1 over e to the v over 6 equals the v equals minus 4 dt. Okay? Going to bring that up as a negative power. So that's how we get around that problem. And now we're going to integrate. Make sure we match them up properly. T1 on top, 3 on the top, 6 on the bottom, and 0 on the bottom. Now we're ready to do this, okay? Now remember the rule about integrating e. What's the general rule? It never ever changes its power. So it was phi over 6, now it's still phi over 6. Okay? Alright, so basically when you integrate phi over 6, okay, what will happen is you're going to be ending up, when you differentiate that, you're going to be multiplying it by minus a sixth. you need something to prevent that from happening, the -6 appearing at the front. So to prevent that, you're going to have to multiply it by -6. Okay, so that's going to be in here. So it's going to be -6 e to the minus phi over 6, and close that in brackets. Okay, still from 3 to 6. And then on the right hand side, we're going to have -4t. We're going to have t1 and 0. Let's integrate. It's going to end up to be -6 to the power of -3 over 6, which is -3 over 6 is very much to the power of a half. Okay. And then we're going to have -6 e to the -6 over 6. -6 over 6 is to the power of -1. And then we're going to have all of that equal to -4t1. Multiplied out, we're going to have does it want it in terms of square roots? It sort of does there, so it's going to be -6 over root e. So I brought the e down below, changed to a square root sign, and this one here is going to be +6 e to the -1, but e to the -1 is basically over e, and that equals -4t1. Multiply both sides by minus, change that to a plus, change that to a plus, and change the middle one to a minus. And then once we got that done, we're going to divide both of them by 4. So we're going to get 6 over 4 root e -6 over 4e. And then we're going to get that this here is going to be t1. Now, I could do a trick here to tidy this up. The trick I could do is I could multiply the top here by root e, multiply the bottom by root e, and what this will in fact will do is say 6 root e -6 all over 4e equals t1, and it'll make it much easier to work with. You multiply any number top and bottom by the same amount, it doesn't change the value of that number. Keep this in mind for t1, okay? And the handy thing about the next part is you already have a substantial amount of the work already done for this, okay? So I might even just might keep that there where it was, and I'll show you what I mean, okay? Go back over your old work, okay? And what's going to happen here is you're going to basically have we're now looking for t2, okay? Find the time t2 for the particle to come to rest. So phi equals 0 this time, and we're looking for t2. So it's a matter of reusing all our work, alright? Except the top limit is now 0, and the top limit on the other side is t2. So you can see there's no point going through what we've already done. So we're just going through and adjusting. We're jumping right back on board from this part here. Okay? And then once I have that part done, the rest of it has to go. So basically you're reusing all your answer from part 1. Okay? So what's going to happen here is we're going to get -6 e to the power 0 minus -6. It's still e to the -1 like it was last time, because if that's a 6 then it's -1. Close it, equals -4t2, and then that's going to be -6 because e to the power 0 was 1. It's going to be +6 over e, and that equals -4t2. Multiply both sides by -1 and divide by 4, so that's going to be a plus. This here is going to be a minus, that's going to be a plus, then divide by 4. We're going to have 6 over 4 minus 6 over 4e equals t2. Now what's going to happen here is, what I'd like to do is I'd like to add in an e top and bottom. So I'm going to have 6e minus 6 all divided by 4e equals t2. Now finally, the combination they want me to use for the last part is t2 minus t1 all over t1. So T2 minus T1 all over T1. Okay, so I'm just going to put it all in and see what happens. Okay, so it's going to be 6e minus 6 okay, so 6e minus 6 all over 4e. Oh, sorry, 6e minus 6 all over 4e minus 6 root e minus 6 all over 4e, and then on the bottom it's going to be 6 root e minus 6 all over 4e. The top and bottom has the same denominator. It means they can go. 4e's disappear right away. Going to put this one in brackets. Okay, so on top what I'm going to have is this. I'm going to have 6e. The 6's are going to cancel because that's going to end up to be a plus 6 when I multiply in. So you're going to have 6 minus 6 root e all over 6 root e minus 6. Now looking at this, what's going to happen is the 6's can cancel, and we're going to be left with e minus root e all over root e minus 1. I see it now. E is basically root e by root e. So that's what e is. Take out root e into root e minus 1, all divided by root e minus 1. The root e minus 1's cancel, hence leaving root e, and that's your answer.